final lecture of pre-calc, 12.4. However, because of the way we set up with 2.6 to 2.7 right before chapter 12, this lecture becomes much easier for you guys. It's almost a review situation. So let's quickly graph this. What do you guys remember from doing 2.6, 2.7? Yep, we're going to have the inverse graph in two different locations. What else? You set this equal to 0, and that tells you at -1. So when you set x plus 1 equal to 0, I should, in case somebody's watching the video, subtract 1 on both sides. X equals to -1. So if you try to plug -1 into this function, it'll give you an error message. You can't use it. What do we know about the horizontal asymptote? I have a first degree polynomial on top and a first degree on the bottom. What happens when it's equal degree? You use what's called the leading coefficient. So the number that's in front of the variable that has the highest exponent, so you go 2 over 1 or y equals 2 would be our horizontal asymptote. And then you could certainly do some plugging in to figure out where you're at. What happens when x is 0?
Y is 0.
Y is 0. Right? So that tells me I must be down here. And then I assume that it's going to be here. And you could plug a number in, say -10. That'd be -20 on top, -9 on the bottom. -20 divided by -9 would be a little bit more than 2 in the positive, if both numbers were negative. So a little more than positive 2. So as I get out here to -10, I know I'm above the asymptote. Okay, so from this, we could ask a bunch of different questions that go along with chapter 12. I can do what's the limit as x approaches -1. I can do what's the limit as x approaches 4. Let's look at those two. What's the limit as x approaches -1? Why? If we're approaching -1, you'd be tracing both sides, and your fingers will start to come together. But then as they get close to -1, right, we're going in opposite direction. So this does not exist. What would happen if I approach 4? 1, 2, 3, 4 would be somewhere out here. If you actually plug in the number, direct substitution works, right? 2 times 4 is 8. 4 plus 1 is 5. So I'm guessing I get 8/5 from my limit. So you got to watch where those numbers are. Now, what we're really working on today is what is the limit as x would approach, let's say, infinity. Now this becomes what's called an infinite limit. It's what's happening to your function as your inputs go way out to the right. Well, what happens? Goes, no, way out to the right. If I continue to go way out to the right, what's this graph going to do? Get closer and closer to the horizontal asymptote. So back in 2.6, 2.7, we looked at some stuff. We actually would touch the horizontal asymptote, cross over it, do all kinds of stuff right here in the middle. But long-term behavior, what happens as we go way out to the right or way out to the left? Same thing can be said if I go to -infinity. It would also approach 2. Now, does the graph ever touch? Once we're way out to the right? No, it's never going to be exactly 2, but mathematically it gets close enough that we would say yes, it approaches 2. Okay? So that's kind of the basic rule today. And what happens then is students assume everything is an infinite limit, and you guys use all the rules that you know and you mess it up. So pay attention to it. If r is a positive real number, then the limit of 1 over x equals 0, that'll happen. And here's what they're talking about. Evaluate the following limits. We're supposed to be approaching infinity again. So what we can do is the limit as x approaches infinity of 3x to the 4th over x to the 4th plus what is the limit as x approaches infinity over negative 5 divided by x to the 4th. So the math mumbo jumbo says you split it up into different parts, the limits. But if you guys think back to the 2.6.2.7 rules, all we're looking for is what's the size of the degree. So what happens when you have x to the 4th over x to the 4th? They're equal degree, right? So it's going to go to 3 over 1, or 3. What's going to happen when you have a 0 degree, the constant function is 0 degree, over the big degree on the bottom? 0. So 3 plus 0 is 3. Because negative 5 is never changing, right? But they're telling you x, x is infinity, so it's not 1,000, it's not 1,000,000, it's not 10 million. I mean, that thing is getting massive. Negative 5 stays put, it eventually goes to 0. It levels off at its horizontal asymptote. Yeah?
Yeah.
So what we're really doing is our horizontal asymptote rules from 2.6 to 2.7. What's the degree on top? That's a first degree. What's the degree on the bottom? Second degree. What we talked about in 2.6, 2.7 is that what happens when the big degree is on the bottom? The horizontal asymptote would be y equals 0. So if you graph this, you're going to see it do whatever it wants, but eventually it's either going to come down against the 0 or come up and against 0. What do you have here? Now we have to be careful. Make sure they're in that descending order, right? The easiest way to trip you guys up is to turn things around and not put them in order. But this is a 1 there and there. So what's 1 over 1? And the last one? Third over second. We might say big over small. What was it? Who said the slant, right? What did that mean? What did slant asymptote mean? We had something that was either going up and to the right maybe, or down and to the left, something, right? And the graph would just continue to follow it up. It never leveled off, right? So,
Long division.
if the graph continues, if a graph continues to go up, or maybe down forever,
That's 0.
where's it going?
Infinity.
Okay?
We don't even have to solve for